Hi everybody, in this video today we're going to be talking about, it says lesson 5.5, I think this is actually lesson 5.6, but we're going to be talking about how to graph polynomials. In order to graph polynomials, you have to know how to factor, and we've spent a lot of time factoring this year, so hopefully we're pretty decent at factoring. So we want to look at this polynomial and decide how can we factor it. I see a GCF. I see that I can factor out a GCF of negative 2x squared, and that's going to give me x squared minus 1. Now I have to keep going. If I can continue to factor, I do need to. And x squared minus 1 can also be factored one more step. So I'm going to keep my GCF here, negative 2x squared, and then this factors down to x plus 1 and x minus 1. So I have a spot here for the factored form. The factored form would be that f of x is equal to negative 2x squared times x plus 1, x minus 1. All right, the next thing I want to take a look at is the end behavior. And from our activity we did the other day on Desmos, we should know what our end behaviors are. And if you don't, you also have that written down in your notes on the parent function page, which is a couple pages over. So I look at this function and it is a fourth degree, and I know that a fourth degree basically goes like this. I want to make sure this is positive, and it's not, it's negative, so I have to go upside down. So I have to go s instead of a w and make an m. That's just a little note to myself so that I know what direction to graph. But the end behavior then is, because it's a fourth power and it's a negative, both of them are negative infinity. So it's going to look like this in the end behavior. Now the zeros, they come from the factored form. And so anytime you have it in factored form, you basically set each of those equal to 0, which we know. Sometimes people get confused when it has this, but if I set this equal to 0 and I solved it, I could divide by 2 and take the square root, and I still get 0. So one of my zeros is at x equals 0. And the other ones, one of them is at negative 1, and one of them is at positive 1. Now, the graphs, we've talked about this a little bit, that in this unit, we don't really care too much how high or how low things go. What we really want to pay attention to is things on the x-axis. So I have a 0 at 0. I'm going to plot that. I have 1 at negative 1 and 1 at positive 1. Now I also want to look at my bend and bounce and things. So we talked about that the other day. If it has a second power, that is a bounce. But if these are both first power, then they're just through, both of them. So I know that I need to have a graph that looks like this M shape. It's going to go through the negative 1 and the positive 1, and it's going to bounce off the 0. So I'm going to try that. I have to start down here, and I'm going to have to end down here. That's my end behavior. It goes through this, it bounces, and it goes through that one. That's my graph. That's a basic shape of the graph. If I wanted to check it, I could go to Desmos and check it, but that is what it would basically look like. Okay, but that's what our process is going to be. We're going to factor it, we're going to think about the end behavior, we're going to write down our factored form and our zeros, and we're going to make a graph. Let's do another one. Once again, I say I have a GCF. So that is a GCF of x, leaves me with 3x squared minus 2x minus 1. That seems like maybe it can be factored. I'm going to try it. You could use AC method to factor, or I use guess and check method. That's how I do it. So I know this has to be a 3x and a 1x. This negative 1 on the end tells me I have to have one of them as a 1 and one of them as a negative 1. I just now have to think about positives and negatives. So if I check this, I would multiply this out. I would want this to be negative and this to be positive. That's going to give me a negative 3x plus 1x. That's a negative 2x. That's how I want it. Okay, factored form. We just came up with it, so let's just rewrite it here. F of x, it's g of x. G of x is equal to x times 3x plus 1 times x minus 1. Okay, what does that say about my zeros? Well, it tells me I have zeros. One of them is here at 0. One of them is here at negative 1/3. And one of them is here at positive 1. So I'm going to go to my graph. Since I have a negative 1/3, I'm going to kind of space out my tick marks here. Okay, so this is a -1, this is a +1. So negative 1/3 is like right here. All right, I have a 0 there, an intercept there. I have 1 also at 0, and I have 1 at +1. And if I look at what's going on, they're all through, all of them. I was going to look for my bends and bounces, but they're all through. The other thing I could look at if I wanted to is y-intercept, but it's just going to be 0, so that's not going to be helpful here. Okay, I need to look at my end behavior. It is a third power, and it's positive. A positive third power has an end behavior that looks like this. That is, this side is a negative infinity, this side is a positive infinity. So that's what I need to do down here. I need to have something down here pointing towards negative infinity and something up here pointing towards positive infinity. All of them are through. So it's just going to go through here, through here, through here, and I have my arrow. And that's it. This video is going to go through all of the graphs, so it might take a while. I'll try to go fast. Again, we need to factor. We have a GCF of x. This is a perfect square trinomial. I recognize that because we studied that in the quadratic unit. That means x minus 3 times x minus 3. So that's my factored form. So then my zeros, I have one of them at 0, one at +3, one at negative. Oh, wait a second, I rewrote that wrong. Let me rewrite my factored form. They should both be -3. So the way I wrote it is fine, or you guys know that I could just write that as squared, right? Because it's the same thing. So it's the same thing squared, so we can write it like this. That shows us that this one goes through, but this one has a bend. Nope, it has a bounce. This one has a bounce. Okay, so I'm going to go to my graph. I need to get to 3, so my tick marks, I don't have any fractions or anything, so I'm okay here. I have one of them at +3 and one of them at 0. I need to consider my end behavior. It is a third power. It is positive. Third power positive looks something like this. That means that on the left side, it's going to go down to negative infinity. On the right side, it's going to go up to positive infinity. So my graph is going to have a downward arrow this way and an upward arrow this way. It's going to go through 0 and bounce off of 3. So it's going to go up here, through my 0, bounce off my 3, and come back up. It's going to look something like this. And we've talked about how in the y, we're not sure how high this bounce goes, but we just know that it has to go up here, and that's okay. We don't have to be exact.